Hey guys, thanks for joining us. So we're looking at part 3. It should say part 3 here. It says part 2. That's my bad. It's a sphere example. We did part 2 last time. It was the cylinder example, which is a circle extruded. And that's kind of why I moved on to a sphere. It's another simple shape, and it's another shape that is a circle that's extruded. But we're going to extrude it kind of different this time. Before we do that, let's talk about the drawing view. We're at a 100 millimeter diameter for this ball. And if I had an ISO, it wouldn't really make sense because it's a ball and it's going to look the same no matter what on paper. So what we do to show that is a section view, and that's what this is. This is section AA, and that's what this view is. And what you can see this as is someone took put it on a bandsaw or something and sliced right through the middle of the ball, and then they took that slice and turned it 90 degrees to show you it. So it's a pretty cool different way to show that this is a three-dimensional ball and not just a circle on a paper. Because if I just showed you 3 different circles and even an ISO, you wouldn't see that it was solid and rotated around in a ball. So that's what we did to show this. I'm sure there's actually maybe even a better way to show that this is a ball on this. This is the way I know. So if any of you guys know a better way, pop it in the comments. I do want to learn too. This is as much a teaching and learning two-way street as anything is. So let me know if you know anything better on that, but this is how I would have done it, and this is how I did it. So part 2 sphere example is a section view cut in half. That's that half, and we're at 100 millimeter diameter. So let's pop over and do it. First things first, as always, we're in a new part. We're in a sketch on the front plane. I'll back out so we can pick that and actually talk about that real fast. We're in millimeters, so let's sketch. If we go on any of these planes, if we sketch it right, where we put the halfway point of the circle that we're going to revolve around the axis at any plane, it should come out the same center of mass property. So let's be thinking about that stuff when we do it. And we could tell from our image over here, we didn't really get that. I didn't really give it that time. And that was for that specific reason, that the mass property can be made any way as long as you do it right. Because we're going to assume that the origin point is at the center. All right, so let's do this. We have our circle tool. We could easily just go 100, which gives us that 100 diameter. But and I'm going to show you what doesn't work here. You might think that you could just grab this and then like maybe extrude it, but we did that last time, right? And that's going to go in one direction. So that's just a cylinder. So you look at your other features. You have your revolve, and we don't really have an axis of revolution to do anything on. To revolve something, you have to do it around something, right? Like when you're making like a pottery, imagine that thing is spinning. The axis of rotation or revolution is directly straight down the center of that plate that spins, and it's perpendicular to the plate. So looking at this now, this wouldn't work. So let's do what does work, and let's think about what would work in this. If we need something to revolve around, let's back out of that revolve tool. Let's go back to our sketch tools. If we put a center line down, we would think that we could revolve around this construction center line. But that also wouldn't work because we would end up creating geometry over itself. As this revolved 360 degrees, you would overlap material, and SolidWorks doesn't like that. So we're also not going to do that. We're gonna do the one thing I like to do with this. This is the easiest way. Let's cut this circle in half. Let's make a half moon, and let's trim this edge. Now we have, imagine a 1/1000th or 1/millionth or whatever type slice of this ball. This makes sense, right? If we start to spin it around that axis and we fill in as we spin, it wouldn't go over itself and it would fill in the ball. So we can do this 360 degrees, and SolidWorks will accept that. So let's go back over to our feature tool and let's revolve it. So the axis, of course, is going to be that line, and we can see SolidWorks automatically fill it in. So that's cool. Let's go back to our sketch and look at something now. Because we used that circle tool and we made it at the origin, the center point of this arc is the origin, which creates the center of mass at the origin as it revolves. So if you look at our center of mass, it's going to be 0. And let's go back and think about this. If we did it around any plane, a half moon and revolved, and we were around that center point, we would always have 0, 0, 0 for our mass property center of origin. Our mass would always be the same as well because we're not changing the density or the material or anything like that. So none of this would change. So that's why in this type of view, you don't really need that kind of specificity. Now, if someone wanted it, they could easily put an origin point down here at the corner, a little origin dot, and that would change everything drastically. We would need to go back to our sketch, and we would need to make this out here. We would draw our circle and make our relation to that, and I could show you that real fast. It's not all that bad. A quick circle that we're going to say is 50 radius, so 100 diameter. And if we take this and we tell it the dimension from this is 50. Oh, let's not do that. We tell it this dimension. I'm in trouble here. Is 50. Well, this actually should be 100. What am I doing? Wait, what the hell? What's this diameter? Oh, that's why. I don't know why that happened. We saw me put in 50, but the diameter changed. So that's weird. Let's fix this. There we go. That was what I was expecting to happen. Ooh, not that. So you can see how quickly errors pile up on you within SolidWorks. So let's delete this and back out. Sometimes it is a little bit easier just to, and this is actually something I was taught by my teacher in SolidWorks. It's a lot easier to just start over than it is to fix in SolidWorks. And I will attest to that 100 times over. So when things start getting weird and you start thinking things should work, delete the part and start over. It might just be faster, it might be easier. So deleting that feature worked this time, which was cool, but sometimes it doesn't. But now we have our 100 diameter, 50-50, and we can now put our line down, which we learned earlier, and we can trim this because all the relations are to this center point, which is what we like. And now if we revolve it, I keep jumbling that word, sorry. We'll see that that ball is, like I talked about now, off of that center point, that origin. And all of our mass properties centers should change, except for our Z. And that one would only change, if we think about it, every time we change the plane we extrude on, I believe. And we can correct me if I'm wrong on that. Yeah, I believe it's only the plane. Someone go do some testing in another and on your own and maybe comment and let me know if that's wrong. But I believe that one would always be 50-50 and 0. One of those would change depending on the plane you revolved around at this point now. But before, like we said, it wouldn't because we were right on that center. So depending on what your drawing asks for, you build it that way. This one we're making some assumptions like we normally do, that we're assuming that they made it built out from the center because that makes things in the center of mass simpler. Okay, I think that's all for the ball example. Pretty cool. We learned a few different things. Revolve tool, center of axis for revolving, and the different ways it messes with the mass properties, and the different planes that you could do with symmetrical objects. All right, next simple tool, we're going to do a few of these basic shapes. I think I only have 5 of them, is a pyramid. All right, we're going to work on that. We might do, I think, a 3-star and a 4-star base. All right, thanks.